Hello everyone, my name is Maulidyna and today I will present to you about our research and the title is Multi-Dissolute Single Port Output Adaptive Power Charge Using Fuzzy Logic Controller. And in our team there is me, Maulidyna, Indhana Sudiharto and Farid Mudianto. Next, outline. In here I made some part. There is introduction, background, system design, simulation result, and conclusion. Next is introduction. Electronic equipment that is not separated from human life, such as mobile phone, laptop, camera, and the others. Energy sources of electronic equipment generally use a battery. The battery used continuously can reduce the energy stored on the battery, so the electronic device cannot work. It is required charging to keep the electronic device operating. In general, charger for mobile phone, laptop, camera have different charger for each electronic device. Generally, current battery chargers tend to be static at one type of DC load with a certain capacity. So, a different battery charger is needed for different type of DC load. This is considered less effective because one battery charger can only be used to charge one type of DC load with a certain voltage and capacity. Next, from this problem, it takes a system that is able to recharge the battery capable of working adaptive on various types of DC load with different voltage and capacity. Use an adaptive power charge system, the charging process with only one device capable of being used to charge more than one type of device with different charging voltage. So the charging process is more efficient. Next, this is the system design. We use the DC bus 12 volt for source. The DC bus 12 volt will pass through to the SEPIC converter. SEPIC converter is a DC-DC converter that can increase or decrease the voltage by adjusting the duty cycle. Then, after the SEPIC converter, there are two sensors. The first one is voltage sensor and current sensor. The sensors are used to monitor the voltage value and the current value. And also, the sensors are used as a reference to determine the set point. And in here there are three of DC load with different charging voltage. When the one of the loads is connected to the system, the duty cycle will be increased until the current sensor reaches the current flow to the load. When the current sensor reaches the current flow to the load, the system will be known what type of the DC load connected to the system. Is it handphone, camera, or laptop? When the system knows the type of DC load connected to the system, then the charging process will be started. In here, we use the constant voltage method for the charging. To keep the output of the SEPIC converter stable, we use a fuzzy logic controller. So fuzzy logic controller will keep the output of the SEPIC converter stable according to the set point for each DC load. And next, this is the system design of the SEPIC converter. Then this is the parameter we use in this research for SEPIC converter. Next, this is the architecture of fuzzy logic controller. There are some parts. The first one is specification, inference engine, rule-based, and defuzzification. Specification it is used to convert input from Krebs number into a fuzzy set with a membership function. And inference engine it determines the matching degree of the current fuzzy input with respect to each rule and decide which rules are to be fired according to the input field. And the rule-based it contains the set of rules and the if-then condition. Then the defuzzification it is used to convert the fuzzy set obtained by inference engine into a Krebs value. And next, This is the falsification, and this is the input that we use in this research. There are two input, error and delta error, and this one is the membership function of error, and this one is the membership function of delta error. And this one is the rule base that we use. And next, this is the falsification. In here, there is a membership function output of the membership function of output, and this is the surface of the fuzzy that we made. Next, this is the simulation result. In here there are three pictures with three different set points. And the red one is the response system using fuzzy logic controller, and the blue one is the response system using PI controller. In here, the response system when the set point 5 volts. We see that the response system using fuzzy logic controller is more faster to reach the steady state than the PI controller. Then when the response system when the set point 8 volt, that we see that the using fuzzy logic controller is more faster than the using PI controller to reach the set point. And when the set point 19 volt, the system using fuzzy logic controller is more faster than the system using PI controller to reach the steady state. And next, this is the simulation result. We compare fuzzy logic controller and PI controller. And next, this is the conclusion. In this research, the multi-decibel single port output adaptive power charge system using fuzzy logic controller is able to work adaptively according to the charging voltage at the connected load. The fuzzy logic controller works adaptively to adjust the output voltage of the SEPIC converter according to the connected load set point. PI controller needs different calculation for each value of Kp and Ki, so it needs 3 calculations for 3 set points. PI control cannot work adaptively to the specified set point. The result of experiment for the charging process using fuzzy logic controller have been simulated and compared with PI control. Fuzzy logic controller has a faster response than the PI control. It takes 0.5 seconds to reach the steady state with a precision reaching 99.8% and an average error of 0.16% smaller than the PI controller, that is 0.708%. The adaptive power charge system using fuzzy logic controller make it easier to charge various types of loads with one device. Okay, that's all from me, and thank you.